Living in the world of machine learning and artificial intelligence and computer vision, Ben Fisher and I decided to use computer vision as part of our senior project, a bulk of our senior project, because we'll probably end up needing to use that in industry later in our careers. OpenCV is a software library that can do just that. Computer vision. It is a branch of AI, and it attempts to give a computer human vision. It gives it a high-level vision and view of the world around it. So it can recognize things like text, objects, color, video recognition. It can recognize what kind of sport is happening in a video, or whether somebody is shoplifting on closed-circuit television, or whether somebody is drowning. A lot of real-world applications for it. A lot of large companies use it too. So Google, Microsoft, Intel, they all use it in one way or another, probably to much more of an extent than some of these startup companies listed here do, but nonetheless they use it. And probably because it's compatible with many platforms, so the developers of OpenCV have made it possible to integrate it with iOS, Android, Windows. You can use the GitHub repository, and I've installed it and built it on Ubuntu, so it's very well supported on different types of Linux-based operating systems. It's supported on Raspberry Pi, which we'll actually be using in our project. There's a guy, PyImageSearch, that's his brand anyways. He has created a lot of tutorials on how to use OpenCV, and I'll just demonstrate a little bit of what he's created to show what OpenCV can do. A little taste of it. So this is actually the guy who I've been following a lot of tutorials from. And in this video he created, he's demonstrating edge detection and color detection to track a ball over time. So he uses OpenCV, and I'll run it here, to find the color, track the edge, and then track it over time. And it runs fairly well on my machine because I have decent hardware. But as you can see, it works really well. I wrote a similar program to show how it can be used for face detection. And here that is, same video, but instead it's tracking his face over time. So this is the code. If you're interested, I'll talk about that for the last minute or so. This is a cascade. This is Python, by the way. This is a cascade that's used. It's just a large XML file that OpenCV uses to compare against the video stream, which is right here, one frame at a time. So this just starts the window. But what happens is, while this loop is happening, I can grab one frame from the video. If the frame is empty, we'll break out of the loop. Converting each frame to gray actually makes edge detection much easier and much more efficient. And then right here, using the cascade, each face is put into this faces array here. And for each face, you're able to draw a rectangle around it. Then just throw it on the screen, and this is a way to quit the program. And this is how you close all the windows. So it's very simple to write an entire program. Since OpenCV has been constructed, it makes it a lot easier for everyday people to use for different things. It's very powerful, and we're going to be using it for car detection, for license plate recognition, text recognition from that. Hopefully one day you all get to enjoy it too. Thanks for watching.